What if I told you that just the seemingly harmless act of zipping up a folder could actually accidentally expose your entire enterprise network to a catastrophic breach?
Yeah, I mean, it sounds dramatic, but it's true. Today we're looking at why packing up your digital suitcase isn't just about data compression. It's really about surviving this invisible kernel-level minefield of mandatory access controls.
It is a scenario that trips up almost everyone, from exam candidates to, like, seasoned system architects.
Oh, absolutely. We just naturally assume that routine operational tasks like making a quick log backup are completely detached from overarching security policies.
Because it's just a backup, right?
Exactly. But in complex enterprise environments, those two worlds collide violently. And, well, usually without any warning.
Welcome to the deep dive, everyone. We are taking you into a highly specific, incredibly illuminating scenario from Season 2, Episode 37 of the RHCSA Series Independent Guide.
And just to place it for you, Season 2 of that resource spans from Episode 26A through 50.
Right. And our explicit goal today is to master secure archive management and Linux policy integration.
It's a mouthful, but it's so important.
It really is.
Huh?
But before we get into the actual bits and bytes, we have to talk about the visual associated with this source material.
Oh, man.
The visual.
Yeah, picture this. You are standing right in the middle of a glowing, highly technical server room. Racks are humming, lights are blinking, and right in the center of the aisle stands a penguin.
But, not just an average penguin.
Far from it. This penguin is incredibly dapper, wearing a full tuxedo, complete with a little bow tie.
Right.
And he's standing on his flippers, holding a live microphone in one hand and a sweaty, ice-cold soda can in the other.
It's such an absurd visual, but I mean, it perfectly captures the independent, slightly rebellious vibe of this specific guide.
Totally.
Because it's designed for candidates trying to pass the Red Hat Certified System Administrator exam, which is a notoriously rigorous practical test. Yeah, it is serious business. But the guide approaches it with this distinct personality to, cut through the dryness of the technical manuals. Okay, let's unpack this. We have a clear operational goal today. We need to bundle up a set of application logs on a machine called App Server and drop the compressed archive into a destination directory at opt backups.
Sounds simple enough on paper.
Right. But standard discretionary file permissions, like your basic read, write, and execute flags, they aren't our main concern here. We're dealing with Linux.
Right, security-enhanced Linux. And it's crucial to understand where this actually comes from. It was originally developed by the National Security Agency.
The NSA?
Yeah, the NSA. To bring military-grade mandatory access controls to the Linux kernel.
Wow. Okay, so how does that differ from the standard permissions we all use?
Well, discretionary access controls, those standard read and write permissions, they essentially say, you own this file, so use your discretion, do what you want. But mandatory access controls strip that power away completely. They say, I don't care who you are or what you own. The system's overarching, unalterable policy dictates exactly what can and cannot happen on this server.
Man. So our old analogy of just packing a moving box and carrying it out the front door, that completely fails here.
Utterly fails.
Because the building you're moving out of has a highly trained, deeply paranoid security guard.
But that's a great way to put it.
And this guard doesn't just glance at the box. This guard checks your ID, your department clearance, the time of day, and, like, the exact molecular makeup of the packing tape you used to seal the box.
Yeah, they check everything.
And if the strict, pre-approved security label on that box is off by a single character, your operation isn't just frowned upon. It is physically blocked at the kernel level.
That is the perfect way to visualize it. So Linux is the ultimate enforcer. It just doesn't rely on trust. It relies on explicit, predefined rules.
So before we even attempt to slip past this kernel-level security guard, the source material dictates that we build out a highly specific sandbox environment.
Right, because obviously we aren't testing this in a live production environment.
Right. But looking at the parameters, I'll admit, I was a little confused by the complexity of the setup.
How so?
Well, it wants us to generate an exact mix of dummy logs, like app-1.log through app-5.log, and then a completely separate batch of error-1.log through error-5.log.
Yeah.
Why go through the trouble of creating this specific mix? Like, why not just make a single test file and be done with it?
Because a single, isolated test file just doesn't accurately simulate the chaos of a real production application server.
Okay, fair.
In a real-world enterprise scenario, I mean, your log directories are an absolute mess. Applications are dumping operational logs, error traces, raw debug files all into the exact same directory bucket.
It's just a giant pile of data.
Exactly. So the source is forcing us to create this mixed environment to test a very specific capability later on, which is selective archiving.
Oh,
Because if you can't separate the signal from the noise in the sandbox, your scripts are going to fail spectacularly in production.
I can see that. We need to simulate the noise to prove we can actually filter it.
Precisely.
But here's the part that really catches my eye in the setup phase. The guide insists we create a dedicated service account called Backup Manager, change the ownership of our test directories to this new user, and then run the entire backup operation through them.
Right.
But we're on a test machine. We have root access to build the directories. Wouldn't it be, I don't know, 1,000 times faster to just run the archive command as root and bypass the administrative headache entirely?
Faster, absolutely. But it would be a critical failure of Objective 9.1 of the exam.
Oh, wow.
Yeah, and a violation of a core tenet of system administration, which is proper user separation and the principle of least privilege.
Right, least privilege.
Because in an enterprise environment, running daily operational chores as root is a recipe for total disaster. You really have to think about the blast radius.
The blast radius, I love that term, because root has absolutely no boundaries.
None whatsoever.
A simple typo in a shell script can theoretically wipe the entire kernel.
Precisely. And, I mean, we have all heard the horror stories, or lived them.
Oh, yeah.
You know, a junior system administrator accidentally destroys an entire database cluster because they ran a routine backup script as root. They messed up a single path variable, and the script just started recursively devouring system files.
That is terrifying.
It is. So by creating a specific service account like Backup Manager, you artificially restrict that blast radius.
Okay.
If your backup process goes rogue, or worse, if a threat actor manages to hijack the backup daemon itself, the damage is fundamentally limited to what that specific service account is legally allowed to touch.
So you grant the exact amount of access necessary to complete the task and not a single drop more.
Exactly.
So we are intentionally building friction into our own administrative process to save ourselves from ourselves down the road.
It's the administrative equivalent of putting a safety switch on an industrial power tool.
Oh, that's good.
Yeah, like, yes, it takes an extra second to disengage the safety before you cut, but it ensures you keep all your fingers.
Always a plus.
Right. So we use root to build the sandbox, creating the directories, generating the test files, handing over the ownership. But once the environment is built, root steps completely away from the operational task.
Okay, so we have the files, we have our restricted user. But here's where it gets really interesting, and where the source indicates most exam candidates completely hit a wall.
The invisible wall.
Yes, Linux.
Yeah.
The source highlights Objective 10.5, which is managing Linux contexts.
Right.
Our destination directory, opt backups, requires a highly specific context label. It has to be manually labeled varlocked. Why that specific label? I mean, why not just leave it alone?
What's fascinating here is the underlying logic of the mandatory access policy. Remember, the ultimate goal isn't just to zip some files and forget about them.
Right.
It's to allow an automated enterprise backup service to read that archive later and move it offsite. If we just leave opt backups with its default system context, Linux will look at the backup daemon, look at the directory, and say, a backup process has absolutely no business reading random administrative files in the oft hierarchy.
So it just blocks it.
Exactly. The operation will be silently denied.
Because the security guard assumes it's anomalous behavior.
Exactly. By explicitly labeling that directory varlocked, we are legally categorizing those files in the eyes of the kernel.
Okay.
We are explicitly telling the policy, these are log files. Any service that is authorized to read log files may safely interact with this directory. It's a precise authorization handshake.
Okay, so how do we actually update the kernel's rulebook to make that handshake happen? The source lays out a very precise, non-negotiable two-step execution.
Yes, it has to be two steps.
First, we modify the master policy database using the smanage tool. The exact command is smanage fcontext atati varlocked opt backups. That is quite a string.
It is a dense command. And honestly, it scares a lot of newcomers. But it's logically structured if you break it down.
Okay, let's do it.
So we're telling the Linux manager To add, that's the app flag,
Okay.
a specific type, the app flag of varlod. But the critical part is that regular expression at the very end, the opt backups.
Right. What does that actually do?
That tells the policy database to permanently apply this rule to the opt backups directory and absolutely everything that ever gets placed inside it. Dynamically, forever.
Okay. But, and this is a massive trap called out directly in the guide, updating the database does not change the actual file system.
No, it doesn't, and that's where people fail.
Candidates constantly run Manage, the prompt returns without an error, they breathe a sigh of relief thinking they're done, and then their backup operation fails anyway. Why the disconnect?
Because they updated the architectural blueprint without actually sending a construction crew to the building.
Oh, wow.
Yeah. The blueprint now says the door should be red, but if you look at the physical door, it is still blue. Manage only updates the database registry.
Okay.
To apply the change in reality, you must run the second step, which is restorecon-rv oct backups.
Ah, so that's the painter.
Yes, restorecon is the painter. It reads the new policy we just wrote, looks at the actual directory on the hard drive, and physically relabels the innodes.
Got it. And what do those flags do in the NCR and the V?
The NCR makes it recursive, diving deep into any subdirectories, and NCV gives you verbose output so you can verify that the kernel is actually changing the labels on the screen.
So without RestoreCon, your policy changes are purely theoretical.
Yeah.
And the security guard will still block you.
100%.
It's a subtle distinction, but obviously completely critical for passing the objective. So the sandbox is built, the security guard has the new rulebook, and the labels are physically applied to the directories.
Finally.
Right. With our security perimeter rigidly defined, we switch identities, we step out of the omnipotent root account, and use SU Backup Manager to assume our restricted role. And finally, we execute the archive.
And the core command to achieve this is the classic Unix tape archive utility. You run tar-czf opdapp-logs.tar.gz varlogap-server-app-log.
Okay, let's break that down too.
Sure. We are creating an archive with massc. We're running it through gzip compression with massc, which satisfies the objective of minimizing the storage footprint
Right.
and explicitly specifying the file destination with F.
Okay, but I really want to zero in on the source path at the very end of that command, the app-.log part. There is a beautifully elegant mechanical detail happening right here.
Oh, the wildcard.
Yes. Most people, even those who use Linux daily, assume the tar application is parsing that asterisk and actively searching the directory for the matching files itself.
Yeah, that's a huge misconception. Tar has absolutely no idea what a wildcard is.
Wait, really? None?
None. It's a fundamental misunderstanding of how the Linux shell architecture operates. The shell itself, usually bash in most enterprise cases, handles the wildcard expansion completely independently, long before the tar binary is ever even executed.
Okay, so the shell acts as a middleman.
Precisely. The shell intercepts the string app-.log, goes into the varlogap server directory, matches app-1.log through app-5.log, and essentially rewrites the command line dynamically in memory. Yeah. It hands tar an explicit hard-coded list of 5 individual files.
Which perfectly filters out those 5 dummy error logs we created earlier.
Exactly.
The shell sees errorRAID1.log, compares it to our wildcard rule, determines it doesn't match, and simply leaves it behind. This completely eliminates the need to hard-code specific file names into our administrative scripts.
And if we connect this to the bigger picture, hard-coding file names in enterprise automation is a ticking time bomb.
How so?
Think about it. If you hard-code app1 and app2 into a script, what happens next month when the load balancer spins up a new instance and the application starts generating app3?
Oh, your backup script will silently ignore it.
Exactly. You will have incomplete disaster recovery data, and you likely won't realize it until the CEO is standing on a desk asking why yesterday's transactional data is missing after a major outage.
Ouch. Yeah, nobody wants that conversation.
Nope. Leveraging native shell expansion makes your operational tasks dynamic. They adapt to environmental changes automatically.
Okay, so the command completes, the hard drive spins, and we get our prompt back. We have a compressed file. But I'm looking at the source here, and it's insisting we run tar-tf and lsbanz before calling it a day.
Oh, you have to.
See, I would have just checked if the file existed and moved on. Why this intense level of paranoia?
Because in system administration, existence doesn't prove compliance.
Oh, I like that.
It's true. Assuming a command worked perfectly just because you didn't receive a giant red error message is incredibly dangerous. We have to enter the proof of work phase. We must trust, but verify.
Okay, so we inspect the archive contents without actually extracting them by running tar-tf.
Right.
And this confirms the wildcard expansion successfully isolated our app logs and left the error logs behind.
Exactly.
But the real exam, the moment that proves whether we properly integrated our operations with security, is checking the mandatory access context.
Correct. We run elsmaz against our newly created .tar.gz file. The capital -Z flag is the universal standard in Linux for displaying Linux security contexts.
And the expected output string detailed in the source is intense. It's unconfined_do.object_var_g.s0. Let's demystify that a bit.
Sure.
So the unconfined do is the user, object was the role, but the absolute gold is right there in the third field, the varlage.
That's the magic label.
Right. The newly created archive file perfectly inherited the mandatory access control label from the parent directory we configured earlier. The security guard recognizes the molecular tape. The backup daemon will be granted access to read the file.
The operational task was completely subjected to the security policy, and it succeeded flawlessly.
Brilliant. We passed the exam objective. Time to close the terminal and go grab a coffee.
Not quite,
No.
no. This raises an important question, and honestly, it is the dividing line that separates novices from senior professionals.
Okay, what is it?
How do we ensure we aren't introducing configuration drift into our environment?
Configuration drift. The slow, silent accumulation of forgotten tweaks, orphaned test accounts, and leftover data that eventually brings a stable system down. The source material refers to this as the comprehensive cleanup, or the zero trace phase.
Yeah.
We can't just leave Backup Manager, a bunch of dummy directories, and custom Linux rules laying around on the server.
Because in a real enterprise environment, those leftovers aren't just messy. They are active, highly exploitable security vectors.
Really? Just a leftover test account.
Oh, threat actors love finding forgotten test accounts like Backup Manager. They are rarely monitored by security teams, their passwords might be weak or expired, and they often have lingering, elevated permissions attached to sensitive directories.
Yes.
They're the perfect backdoor.
So we switch back to root to tear down the sandbox. We wipe the directories, and we use user /s to completely scrub the service account and its mail spool from the system registry.
Yep.
But we also have to go back into the Linux blueprint and explicitly delete the custom varlot rule we made for opt backups. And we do that using seminat context data D.
This is so crucial. If you leave that custom rule in the policy database and say 6 months from now, another administrator legitimately uses the ops backups directory for a completely different application, say a database dump.
Okay.
That dump is going to automatically inherit varlot permissions.
Oh.
The database daemon's operations will inexplicably fail because of a ghost rule you left behind. You must wipe the rule from the database to restore the system to its clean baseline state.
Man. So what does this all mean? When you step back from the syntax, the flags, and the wildcards, this entire exercise isn't really about creating a tarball at all.
Not even a little bit.
It's about system hygiene. You aren't just moving files from point A to point B. You are actively managing the persistent state and the holistic security posture of the entire operating system.
We navigated an incredibly complex intersection today. I mean, we took basic shell utilities, layered on dynamic wildcard expansion, integrated data compression, and forced all of it to operate flawlessly within the rigid kernel-level confines of Linux mandatory access controls.
It's a lot when you put it like that.
It is, and we proved that operational agility and rigorous security aren't mutually exclusive if you deeply understand the underlying mechanisms.
Yeah, if your goal is passing the RHCSA exam, or just stepping up your game as a systems architect, mastering this intersection changes everything. You move away from just memorizing commands to actually orchestrating system behavior.
It's the profound transition from knowing what to type to knowing exactly why the system responds the way it does.
Absolutely. But before we wrap up this deep dive, I want to leave you with one final thought to ponder.
Let's hear it.
We spent a massive amount of time today dissecting Linux, our hyper-strict security guard. Linux forces us to explicitly define who is trusted to do what, down to the granular level of a single directory label. It demands absolute, unwavering intention.
You really cannot fake your way through mandatory access controls. You either know your architecture or you don't.
Right, so think about this. If a seemingly simple archive command, just bundling up 5 tiny text files, requires this much intentional, explicit security planning to execute safely, how many hidden, catastrophic vulnerabilities are sitting right now in massive enterprise networks?
So I shudder to think.
How many systems are out there right now where administrators just disabled Linux entirely, setting it to permissive mode simply for the sake of convenience,
It happens all the time.
because dealing with the security guard was too much administrative friction. If you completely bypass the guard at the front door just to save 5 minutes packing your moving box, who else is walking into your building while you aren't looking?
That is a terrifying and unfortunately very necessary reality to consider.
Something to keep in mind the next time you are tempted to type set and force a 0. Thanks for joining us on this deep dive into the RHCSA sources. Keep exploring, keep questioning, and we'll see you next time.